We're in 4.4 again, and today we're doing domain, range, and graphs of log functions. So we know how to convert between log and exponential functions, but let's talk here a little bit about the graphs of them. All right, domain and range of log functions, and the essential thing to know or remember is that log functions and the corresponding exponential function are inverses of each other. Remember, the primary rule about domain and range of inverses is that the domain of the first becomes the range of the inverse, and the range of the first becomes the domain of the inverse, okay? All right, so let's remember that the domain of a log function then will be the same as the range of the exponential function. Remember, the range of exponentials are all real numbers in their, domains of exponentials are all real numbers. Let me write this out here. Let's make sure we're comfortable with this. Okay. So, oh my goodness. All right, that's the problem. Hold on, gang. We can get this guy going again. All right, let's go over here. All right, so in a basic logarithmic function, all right, let's think about the most basic exponential function, y equal 2 to the x power. Basic exponential function, the domain is all real numbers. You can plug in any value in the x, but you're going to get a range that's always positive from 0 to infinity, because even a negative x value is just going to mean that you flip it upside down. It doesn't actually mean that the problem becomes negative. All right. Now, that's the basic one, basic a to the x. If you put a negative in front of here, then that's going to flip it across the x-axis, and then your domain and your range changes based on your transformation. But the basic one with a positive a value to some x value, domain is negative infinity to infinity, range is 0 to infinity. Now, let's rewrite this, make the inverse. The inverse, you flip your x and your y. So now I've got x equals 2 to the y. And if we rewrite this in log form, this is log base 2 of x equals the exponent y. The 2 is the base. The exponent is the answer on the other side of the equal sign, and the x goes in the blank space. Now, the domain and range are not hard to figure out here. The domain is going to be the range of the inverse. So if the range was 0 to infinity, that becomes the domain of our new one. Our domain was all real numbers. Now our range is all real numbers. And if we put these both in our graphing calculator, you will see pretty clearly. Let's do 2 to the x up here. All right, that's our original. And then here is its inverse. And I haven't yet taught you how to do this. No, log base x. But we will in a different lesson learn how to put these in. But until I teach you how to put them in, just trust me. But you can at least see that these are inverses of each other. All right, there's your original one, negative infinity to positive infinity, domain, but the range, it's 0 to positive infinity. And then here's the inverse, which is a reflection across the y equal to x. This is log base 2 of x. Notice that its domain starts at 0, domain 0 to infinity, but its range goes down from negative infinity to positive infinity. Okay. All right. So the domain of the one becomes the range of the inverse and vice versa. All right. Now, if we're going to graph these are reflections of the corresponding exponential function across the line y equal to x. Letter A is if you had a fractional base, all right, a base A between 0 and 1. Letter B is if you have a base that is greater than 1. And these are both reflections across the line y equal to x. All right. What about ln of x? ln of x stands for the natural log of x, and that's a log with base e. A log with base e. Okay, so let me share here again. All right. So remember, e we defined previously as the limit as n approaches infinity of 1 plus 1 over n to the n power. So that would approximate this number e, all right? About 2.7 so-and-so. Now, if you have log base e, we shortcut that with and call it the natural log, and that is ln of x. So if you see ln of x, it's the same thing as saying log base e of x. And then if you see log with no base, that is log base 10. No base, you can assume it is a base 10. All right. Now let's talk about domain then if we pick it up and we transform it. All right, let's transform something. And I've got one right here, a basic log function here at the top. Log base 2 of x minus 5 equals f of x. All right, remember, for just plain old log base 2 of x, we said that our domain was 0 to infinity. Okay, but now, and so this right here, this part in the basic one has to be greater than 0. It's 0 to infinity, not going to be negative. But I've picked mine up and transformed it. And so instead from going to 0 to infinity, it's now going to have to, it's going to be picked up and moved right 5 units horizontally. And the whole x minus 5 now has to be greater than 0. And if you solve that, add 5 to both sides, x has to be greater than 5. Now my domain after this transformation of moving it right 5 units is that my domain is x greater than 5. I didn't change my range. My range is still all real numbers. Okay, but now I picked it up and moved it right 5 units. I'm going to put that on the graphing calculator for you too. Let's clear all these guys off. All right, so what we're putting in here, and again, I have not yet taught you how to do this. And this will be in a later lesson, how to put these guys in here. Oops. All right, so now let's zoom to the standard window. All right, so we're putting in this one, and we had to think of your original log goes like this. We picked ours up and moved it 5 units to the right. So our new domain is from 5 to infinity out here on the x-axis, but our range is the same from negative infinity to positive infinity. Okay. All right, so natural log we said is log base e. Let's find the domain of the logarithmic function. We're going to graph a log and its inverse. F of x equals negative ln x plus 1. And first we're going to graph it. All right, so what are we going to do? We're going to take the basic natural log function. We're going to flip it across the x-axis, and we're going to move it right 1 unit. Okay, flip it across the x-axis and move it right 1 unit. Okay. By the way, remember, then I bet I've got this written down for us. Let's look at this. So this is the function we are working with here. All right. Y equals the natural log of x plus 1. We picked it up and we moved it right 1 unit. Okay. So now our domain, this x plus 1 has to be greater than 0. And so now our domain, x has to be greater than negative 1. Our domain is negative 1 to infinity. Our range is still negative infinity to infinity. This means we're going to flip it across the x-axis. It's negative outside. So, but still, that won't, it doesn't matter whether you flip it across the x-axis, you're still going to be going from negative infinity to infinity. All right, now to get the inverse, though, that's what we want to do. To get the inverse, we're going to switch our x and our y. So I'm going to have x equals negative ln base e of y plus 1. And to switch my x's and my y's, And then I move this negative over the other side. So now instead of having y, I've got x, and I move that negative over there. So that's negative x. Ln, which is natural log, so log base e. And instead of x here, I've got a y. And that's how you get your inverse. Okay, you switch your x and your y. Now that I have negative x equals log base e, basically of y plus 1, I can rewrite this in exponential form. This is e to the exponent negative x, so e to the negative x equals what's in the parentheses, the y plus 1. Then solve for y by subtracting 1 from both sides, and I get the, those cancel out. I get that my inverse function is y. So we could call it y inverse equals e to the negative x minus 1. E to the negative x minus 1. All right. Now, you might think, oh, that's kind of hard to find the domain and range of that one. Not if you knew the other one. Domain of the inverse is the range of the original. All right, my range of my original was negative infinity to infinity. So that's my domain of my inverse. My domain of my original was negative 1 to infinity. That's my range of my inverse, negative 1 to infinity. All right, and if you were going to graph it, you start off with your basic e function, flip it across the x-axis, and move it left 1. And you can see here by this third one that our domain starts from negative 1 to infinity. All right. All right, common log is log base 10. We've already talked about that. So let's do f of x equals 2 log x minus 2. All right, and let's think about this a little bit. 2 log x minus 2. All right, first of all, let's just look at this original one. We're going to graph the original one. Main thing you need to know about the original one, all right, it's going to be a stretch of 2. And then this x minus 2 means we're going to move it right 2 along the horizontal axis. All right, so remember that the domain for the log, this thing has to be greater than 0. Okay, so x minus 2 has to be greater than 0. So x has to be greater than 2. Our domain is x greater than 2 or 2 to infinity. But the range for all these log functions are negative infinity to infinity. Okay. Then we need to find the inverse. So the y becomes the x becomes the y, and now we need to rewrite this and see if we could solve for the y. And the way we do that, first let's move this 2 over the other side. So I have x divided by 2 equals log of y minus 2. All right, remember, log without a base is log base 10. So if I want to rewrite this in exponential form, I've got 10 to the x over 2 power, or 1/2 x power, is going to equal y minus 2. And now to finish getting the inverse, I can just add 2 to both sides. This is y then equals 10 x divided by 2 plus 2. Just added 2 to both sides. So 10 or 1/2 x, 10 to the 1/2 x power plus 2. Now you might again say, well, gosh, that's going to be hard to find the domain and range. That looks complicated. No, it's the simplest thing ever. Okay. Domain of this inverse function, okay, is the range of the original. The range of the original is negative infinity to infinity. So now the domain is negative infinity to infinity. The range will be the domain of the original. The domain of the original is 2 to infinity. So now for the inverse, the range is 2 to infinity. Okay. All right. So if you take the original, log base 10 of x, when x is 1, y is 0, when x is 10, y is 1. Pick it up and move it 2 units to the right. So instead of 1, 0, you got 3, 0. Instead of 10, 1, you've got 12, 1. And then we're going to stretch it by a factor of 2. Okay, so it's 3 zeros says 3, 0, but 12, 1 becomes 12. And then 1 times 2, which is 2, stretched by a factor of 2. All right, we already found our inverse and our domain and range. And if you graphed your inverse and your original, they're going to be reflections across the line, y equal to x. All righty. So with that, we will stop this one. And your keyword is the range. The range for log functions is all real numbers. So you could say, all real numbers. Okay. All real numbers. All right. We'll see you in the next video.